Good morning, students. In a previous class, that is in class 3 of the chapter Basic Concept of Chemistry, I already completed the fundamental idea about equivalent mass, atomic mass, gram atomic mass, molecular mass, gram molecular mass, and discussing about the concept mole concept. Mole concept. So today in class 4, today the class 4, again we continue about some little idea about the mole concept. So day before we go through a relationship with mole concept. I repeat again, mark that. Number, that is Avogadro number 6.023 into 10 to the power 23 molecules equivalent to gram molecular mass, that is equal to GMM, equivalent to gram molecular volume GMV, equivalent to 22.4 liter at NDP. Day before we continuing the relationship, this one GMM equivalent to GMV equivalent to the number Avogadro number of molecule is equal to known as 1 mole. So 1 mole molecule means it contains 6.023 into 10 power 23 number of molecules. 1 mole, any substance at NDP possesses the volume of 22.4 liter, and the gram molecular mass depends upon the formula of the molecule. Already we completed the relationship between number and gram molecular mass, and relationship between gram molecular mass and gram molecular volume. Today in class 4 we reduce a relationship between number and gram molecular volume, that is GMV, and its value is fixed, that is 22.4 liter at NTP. Mark that. That is number equivalent to the volume. I write again, that means 6.023 into 10 to the power 23 molecules, that is Na Avogadro number, equivalent to 22.4 liter at NDP. Mark the relationship. This much number of molecule at NDP possess the volume. Now frame the question. Mark that question. Calculate the volume possessed by 6.023 into 10 to the power 22 number of CH4 molecule. Mark the question. I always advise to you, read the question carefully and focus to two relations. What the two terms are given? What are the two different terms given? Mark that. Calculate the volume means you write GMV possessed by this number. Number means 6.023 into 10 to the power 23. So first you frame this relationship is equal to 22.4 liter at NTP. Then focus to which one molecule? CH4. That means Avogadro number, this number of molecule possess 22.4 liter. Then one molecule possess this much by this one, and therefore 6.023 into 10 to the power 22 number of molecules possess a volume is equal to 22.4 divided by 6.023 10 to the power 23 into 6.023 into 10 to the power 22. This one cancel, is equal to 2.24 liter. Mark that. So the volume possessed by this amount number of methane molecule is 2.24 liter. Let us solve another one problem. Mark that. Question number 2. Calculate the volume of 3.01 into 10 to the power 21 number of CO2 molecule. Mark the question. Same question is there. That is a volume and a number. That means for CO2 molecule. For CO2 molecule, 6.023 into 10 to the power 23 molecules possess a volume is equal to 22.4 liter. So the volume possessed by 3.01 into 10 to the power 21 number of molecule is equal to, mark that, is equal to 22.4 divided by 6.023 into 10 to the power 23 into 3.01 into 10 to the power 21. Cancel 2. It is 10 to the power 2. That means 11.2 by 100. This is equal to 0.112 liter. Mark that. Irrespective of the molecule, it is maybe methane, maybe carbon dioxide, maybe ammonia, oxygen, nitrogen, chlorine, whatever it may be, its GMM, molecular mass, equivalent to GMV, that is 22.4 liter, equivalent to Avogadro number of molecule. Now change the relations. Mark that. Now first we write number with volume. Now we write volume with number. That means 22.4 liter of 22.4 liter volume at NTP equivalent to number contains 6.023 into 10 to the power 23 number of molecules. Mark the relationship. Just rotate this one. Then frame a question. What is the question? Mark the question. Calculate the number of CO2 molecules present in 5.6 liter. Mark the question. Focus. What is the question? Question is calculate the number. Number means 6.023 into 10 to the power 23. Then 5.6 liter of volume means 22.4 liter. So 22.4 liter of CO2 molecule possess this number of a molecule. Then therefore the total number of molecules CO2 molecules present is equal to 6.023 into 10 to the power 23 divided by 22.4 into 5.6. Cancel, it is 4. So it is equal to 1.5 into 10 to the power 23 number of molecules. So it is a little idea about the relationship between number and volume and number. So mark that. Now we complete relationship number with mass, mass with volume, and volume with number. Now related to mole, mark that. In the previous class, already we discussed this one. Again, I try to repeat it. That means 6.023 into 10 to the power 23 number of molecules is equal to gram molecular mass is equal to gram molecular volume, that is 22.4 liter at NTP. This is equal to 1 mole of molecules. Now mark that. So in previous class already complete the relationship number and mass and number, then relationship mass with the volume, volume with mass, relationship number with volume, and volume with number. Now we continue relationship with mole with number, mole with mass, and mole with volume. So first we start mole with number. Mark the relation. 1 mole of any molecule contain 6.023 into 10 to the power 23 number of molecules. So mark the relationship. Now proceed to solve 1 or 2 question. What is the question? We frame the question, then try to solve it. Mark the question. What is the question? Calculate the number of CH4 molecules present in 2.5 mole. Mark the question. Number with mole. So we know that answer. We know that 1 mole contain 6.023 into 10 to the power 23 molecules. Therefore, total number of molecules present is equivalent to 2.5 into 6.023 into 10 to the power 23. Multiply this one. This is the result. This is the number of total methane molecule present in 2.5 mole. Similarly, move another one question. Calculate the total number of carbon dioxide molecule. Calculate the total number of CO2 molecule present in 1.25 mole. Are there? It may be carbon dioxide, may be methane, may be nitrogen, may be oxygen. Same concept is there. That is answer. 1 mole of CO2 molecule contain 6.023 into 10 to the power 23 molecules. 6.023 10 to the power 23 molecules. Therefore, total number of CO2 molecules present is equal to 1.25 into 6.023 into 10 to the power 23. Multiply. This is equal to the total number of molecules. So in this concept, first we calculate the total number of molecules. Again the question is calculate the total number of atoms of carbon in this mole. Calculate the total number of oxygen molecule in this number of mole. Calculate the total number of atoms, individual atoms, and also total number of atoms present in 1 mole, 2 mole, 3 mole, 0.5 mole, whatever it may be. Okay. Next switch over to relationship with mass with mole. Next switch over to another relationship. That is 1 mole of molecules equivalent to gram molecular mass, GMM. It is the concept. So from this relation, let us try to give one example. That means point 1 for CH4. What is the concept? The mass of 1 mole of CH4 molecule is 16 gram. Molecular mass CH4 is 16 gram. So 1 mole of methane molecule, their weight is 16 gram. Now we frame the question. What is the question? Question. Calculate the total mass. Calculate the total mass of 2.5 moles of CH4. Mark that. Calculate the total mass of 2.5 mole of CH4. So we know that 1 mole of CH4 is 16 gram. Answer. We know that 1 mole of CH4 weight is equal to 16 gram. Therefore, the total weight of 2.5 mole is equal to 2.5 into 16. This is the answer. So as GMM, gram molecular mass, depends upon the formula. So for concept is same. If we change methane, ammonia, carbon dioxide, water, H2SO4, HCl, depending upon its formula, mass changes. But whatever may be, 1 mole equivalent to its molecular mass. Then reverse the relationship. Molecular mass with mole. Mark the. Reverse the relationship. That is molecular mass with the mole. We select carbon dioxide. So GMM, gram molecular mass of carbon dioxide is 44 gram. That means relation is 44 gram of CO2 molecule contain 1 mole. So now frame the question. Calculate the total number of moles of CO2 present in 4.4 gram. Mark that. Gram with mole. So we know that. What do we know? That means for answer, for CO2 44 gram equivalent to 1 mole. So 4.4 gram equivalent to 1 by 44 into 4.4. Cancel out 0.1 mole. So we select carbon dioxide, methane, water, whatever may be, its molecular mass equivalent to 1 mole of molecule. Its atomic mass equivalent to 1 mole of atom. Okay. So relationship with 1 mole with number over 1 mole with gram molecular mass over. Now relation to 1 mole with volume. Now we transfer to the relationship between 1 mole with 1 mole of a molecule with gram molecular volume. We know that gram molecular volume at NTP is 22.4 liter at NTP. This is the relationship. So by this relationship, let us deduce one statement. That means by taking NH3, mark that. Example, for ammonia, that is 1 mole of NH3 molecule possess a volume of 22.4 liter. Mark that. 1 mole of ammonia molecule, the volume possessed by 1 mole of ammonia molecule is 22.4 liter. So next deduce the question. Like that question. Calculate the volume of 2.5 mole of ammonia molecule. Mark the question. I always advise to you, focus to 2 points. Which 2 relationship we have to build up. Mark that. Calculate the volume, one thing, 2.5 mole, one thing. That means answer. What do we know? 1 mole possesses the volume 22.4 liter. Therefore, the total volume is equal to for 2.5 mole is equal to 2.5 into 22.4 liter. This is the answer. So it may be NH3, maybe CO2, maybe H2O, maybe any other molecules is there. At NTP if we discuss, then 1 mole of that molecule possesses 22.4 liter. Now relationship with mole with volume. Now alternate the relationship with the volume with mole. Mark the relationship. Now build up the relationship with volume, that is GMV equivalent to 22.4 liter equivalent to 1 mole of molecules. Mark the relationship. Select one example, that means HCl. Mark that example 22.4 liter of hydrogen chloride contain 1 mole of molecule. Mark that. 22.4 liter of HCl contain 1 mole molecule. 22.4 liter of NH3 contain 1 mole molecule. 22.4 liter of CO2 contain 1 molecule. So next we deduce the formula. Formula is over. Next transfer to the question. What is the question? Calculate the total number of moles possessed by 11.2 liter of HCl. Read the question. What is the focus? This is the volume and total number of moles with volume for HCl. So answer. Mark that. 22.4 liter of HCl equivalent to 1 mole. Therefore, 11.2 liter of HCl is equal to 1 by 22.4 into 11.2. That is 0.5 mole of HCl. So now frame the relationship with moles with volume and volume with number of moles. Now by combining these 4 terms is there. I repeat again. One is a mole, one is a number of molecules, One is gram molecular mass and one is gram molecular volume. 4 parameter is there. Then we interrelated at a time with 4. Mark the relations. That means 1 mole equal to 6.023 10 to the power 23 molecules equivalent to gram molecular mass equivalent to gram molecular volume, that is 22.4 liter RT/dB. Now we find out one term, one factor with respect to 3. Mark that how it is possible. Question. Calculate the number of moles possessed by, calculate the total number of moles possessed by get 1 6.023 into 10 to the power 22 NH3 molecule. That means B2, that is 3.4 gram of NH3 molecule. Third point, 11.2 liter of NH3 molecule. Now the question 1, 2, 3, 4. We have to find out the mole. We have to find out the mole with respect to number, with respect to mass, with respect to volume. So this relation is 1 mole equivalent to this number of molecule equivalent to its molecular mass equivalent to 22.4 liter. So mark that how we solve one by one. First is number. That means answer. We know that, what do we know? 6.023 into 10 to the power 23 molecule is equal to 1 mole. So this much molecule, therefore total number of moles is equal to 6.023 into 10 to the power 23 divided by 6.023 into 10 to the power 22. Cancel 10 mole. Okay, so B1 is over. Then with related to gram, mark that with related to gram. In case of NH3, if we select NH3, so what is its mass? 17 gram. That means answer B2. 17 gram of NH3 possess 1 mole. So by question, that is 3.4. So therefore, total number of moles equivalent to 1 by 17 into 3.4. That means it is 34 by 10, it is 2 by 10, that is 0.2 mole. So first we calculate number of moles with number, next we calculate number of molecules with mole, next we calculate volume with mole. Third bit. Mark the third bit. What is the third bit? That is volume with mole. Means we know that 22.4 liter of NH3 equivalent to 1 mole. Therefore, total number of moles present in 3.4 gram. That means 1 by 22.4 liter into 11.2. That means to 0.5 mole. Okay. So that means we calculate a mole with respect to molecule, with respect to gram, with respect to volume. Now we calculate a number of molecules with respect to mole, with respect to mass, and with respect to volume. Mark that relationship. Question, calculate the number of molecules. Calculate the number of molecules of CH4 present in between 2.5 mole of CH4 between 1.6 gram of CH4 between 5.6 liter of CH4 at NTP. Read the question. Never worry about the question, or it is a numerical, so never worry about it. But always go through the concept. What is the concept? Calculate the number of number. It is the Avogadro number. We have to find out Avogadro number with mole, with mass, with volume. Mark that. Answer. B1. B1 is with mole. We know that. 1 mole of CH4 contains 6.023 into 10 to the power 23 molecule. Therefore, 2.5 mole contain 6.023 into 10 to the power 23 into 2.5 multiply. This is the total number of molecules present in 2.5 mole of CH4. Move to the B2. Mark that. What is the B2? That is a gram. For CH4 we know that. Answer B2. 16 gram of CH4 contain 6.023 into 10 to the power 23 molecule. Therefore, 1.6 gram of CH4 contain this much by 10. That means 6.023 into 10 to the power 22 molecules. So first to calculate number of moles with molecules, then we calculate mass with molecules. Next, third we calculate volume with molecule. Third one. Mark the relationship. Third one. Volume. Volume means answer. Third one. 22.4 liter of CH4 possess the weight equivalent to, for CH4 16 gram, equivalent to the number of molecules, that is 6.023 into 10 to the power 23 molecule. So if 22.4 liter this much number of molecule, then 5.6. Therefore 5.6 liter possess the number of molecules is equivalent to 6.023 into 10 to the power 23 divided by 22.4 into 5.6 is for 1.5 into 10 to the power 23 number of molecules. Okay, so we will reduce the relationship with number of molecules with mole, mass and volume. Now we calculate the mass, relationship of mass with other thing. Mark that how it is possible. Now we calculate this bit over, this bit over. Now transfer to mass with other. Question. Calculate the mass possessed by between 2.5 mole of N2 molecules between 6.023 10 to the power 21 number of nitrogen molecules with 3, that is 5.6 liter of nitrogen molecules. Mark the question. If one is able to know the concept, then automatically build up the question and also the answer. Mark the answer. Answer B1. What is the question? Mole with mass. For N2, nitrogen, that means we know that 1 mole of N2 gas possesses 28 gram. That means total mass, therefore total mass of 2.5 mole is equal to 2.5 into 28. This is the total mass of 2.5 mole of nitrogen molecule. Move to the second one. What is the second one? Number. That means we know 6.023 into 10 to the power 23 numbers of N2 molecules possess weight 28 gram. Therefore, 6.023 into 10 to the power 21 number of N2 molecule possess 28 by 6.023 into 10 to the power 23 into 6.023 into 10 to the power 21 cancel by 10 0.28 gram. Okay, so first one calculate mole with mass, mole with mass, then number with mass, the last one that is the volume with mass. Volume we know that is bit 3, 22.4 liter of N2 possess a mass 28 gram. Therefore 5.6 liter N2 possess 28 by 28.4 into 5.6 divided by 4 is 7 gram. Okay, so to deduce the relationship with mole with one molecule, mole with mass, next we calculate volume with the other three. Like that. What is the relationship? Calculate the volume of CO2 possessed by which one? 0.1 mole of CO2 with 6.023 10 to the power 22 number of CO2 molecules with 3, that is 4.4 gram of CO2 molecule. Mark that. How we solve bit 1 answer. Bit 1. Calculate the volume of 0.1 mole. We know but 1 mole of CO2 volume is 22.4 liter at NDP. Therefore, 0.1 mole of CO2 possess volume 2.24 liter. Okay, bit 1 over. Then transfer to bit 2. Mark that. What is bit 2? That means number answer. That means 6.023 into 10 to the power 23 molecules possess a volume 22.4 liter. Therefore, 6.023 into 10 to the power 22 molecules possess by 10. That means 22.4 by 10. That is 2.24 liter. So relationship with mole with volume, number with volume. Next, mass with volume. Like that. What is the relationship mass with volume? Mass for carbon dioxide we know that gram molecular mass 44 gram of CO2 possesses volume 22.4 liter. So therefore 4.4 gram of CO2 possess 22.4 by 10, that means 2.24 liter. So it is a little idea about the relationship mole with number of molecules or number of atoms, number of ions, number of electron, proton, etc. Then with mass, then with volume. So switch over to last another type of problem. That is, calculate the mass of carbon dioxide. Note down the question. Calculate the mass of carbon dioxide. Question. calculate the mass of carbon dioxide molecule which contain the same number of molecules as are present in 40 gram of oxygen molecule. What is the question? Calculate the mass of carbon dioxide molecule which contain the same number of molecules are present in 44 gram of O2 molecule. So first we calculate the number of moles. Answer. First thing we have to calculate the number of moles present. That means for O2 that is 32 gram is equal to 1 mole. If 32 gram is equal to 1 mole, therefore 40 gram is equal to 1 by 32 into 40 equal to 1.25 mole. So 1 we know irrespective of carbon dioxide or it may be oxygen, 1 mole contain Avogadro number of molecule. That means 1 mole of CO2 contain 6.023 into 10 to the power 23 molecule. Therefore, the total number of molecules of CO2 present in 1.25 mole is equal to 1.25 into 6.023 into 10 to the power 23. Multiply this one. This is the total number of molecules of CO2 present, which is equivalent to the total number of molecules present in 40 gram of oxygen. Okay. So last, move to another one type of problem. Next question. Note down the question. The cost of table salt. Do you know what is the formula of table salt? That is sodium chloride. The cost of table salt, NaCl, and table sugar, that means C12, H22, O11 per kg is 20 and 40 rupees respectively. Calculate their cost per mole. Mark that. C12H22 or 12 or 11. Okay. So mark that. What is the question? Question is the cost of sodium chloride and sucrose per kg is given rupees 20 and rupees 40. We have to calculate per mole. That means answer. For 1 mole of sodium chloride means its molecular mass NaCl, that means 23 plus 35.5 is equal to 58.5 gram. That means per kg data is given. So the cost for 1000 gram of sodium chloride is given. Then we have to calculate the cost of for 1 gram and cost for 58.5 gram. Mark that. Answer. The cost for 1000 gram, the cost for 1000 gram of sodium chloride is equivalent to 20 rupee. Rs, that means is equal to Rs 20. Then for 58.5 gram is equal to 20 by 1000 into 58.5. Solve this one amount of rupee, or rupee is transferred to pies. 1 rupee is equal to 100 pies. Similarly for the sugar, the molecular mass of sugar, that is GMM of sugar is equal to 342 gram. So according to question given, the cost of 1000 gram of sugar equal to Rs 30. That means therefore the cost of 342 gram of sugar is equal to 40 divided by 1000 into 342. Solve this value. What is that value? Is equal to the total cost of 1 mole of sugar. Either your answer may be transferred to in form of rupees or in form of the pies. It is a little idea about the mole concept.